So today's topic is system task in Verilog. So we are writing some task and function inside some memory or some compiler related thing. We don't have to worry about that, but there are some function and task written already. We are using that function and task, and that is called system task. So because system has already created some task, and we are using that. So what is the definition? System task in Verilog are built-in procedure. So some procedure or process we are writing in function, and that is written only inside your function, and we are using that function provided by the Verilog simulator. So that function is simulated in simulation time, used only during simulation, not a synthesis. So it is not synthesizable, but we are using this because we need this. Now I haven't created video for a function and task in our playlist. Other than that, I have videos for function and task, but I will create this function and task videos in future, so you can watch in this playlist also. Now, for example, if it is your EDA playground, something, this has our page. Okay, so you are writing some module and module. So who is defining this module and module? There may be some file created for this, right? This module and already is declared on this. Similarly, that our function is also declared outside our this file, the main file, the top file or recipe file. So some things are already defined. So this function are written here. We are just using the function name like a, and we are just using this function. So this is our system task already written, and we are mostly they are functions, and we are using this. Okay, let's move forward. So there are some categories of system task, and for example, for displaying, simulation control, file, time related stuff, and assertions. Okay, so let's move. So for printing, we are using $display. Now $display simulation, all this system task, $display, monitor, right? I will tell you about how to write the code, but already created how it is simulated, so you can watch my video on event regions and you will understand that. Now, so $display, its print statement, so syntax is very simple. $display and value of a means this is your printing line which will be printing on your terminal, and this is our what you say, I define that the decimal will be there, and a will be having value of decimal after printing. For example, if a is binary, but it will print our decimal. Let's take an example. If a is 01, means a is 1. Now, so the printing statement will be value a equal to 1. This one, not this one. Okay, so this is our printing statement. You can write in our inverted commas, and you can print the value of a. Similar to that, our monitor is there also for printing, but it whenever the sensitivity list changes or input changes, it will print. For example, if a is declared here in code, its value is 1 as I already declared, but after displacement its value changes to 2. So this display statement will not print this 2 value, but monitor statement will print this 2 value. Every time the a will change, the value will be printed by the $monitor. Rest of the things are same, and in $monitor I will $time we will come in a future slide. So $strobe similar to $right and $monitor, but $stop prints at the end of the simulation. For example, there are regions. Okay, I will just summarize it like active region, inactive region, NBA region, and monitor region for Verilog. So this strobe will execute in monitor region, and right will all execute in active region, display will active region, monitor will on monitor region. $right is similar to our $display, but for next line we have to add /n. For example, 2 statements are there, so it will directly print 2 statements, one statement this, one statement in this. For $display, it will print this statement, then in next line you will print second statement. So this is the difference between $right and $display, but we will use mostly $display, and strobe is similar to $display, but execution time is different. Okay, now simulation control task. So controlling simulation, we are using this $finish and $stop. So end of the simulation gracefully, it means that if $display is called, the simulation will end, and the syntax is simple. Just write $finish inside initial block or any block. Just write dollar finish. After some delay, you can write like hash 1000. So hash 1000, after hash 1000 the simulation will end. So for ending the simulation we are using dollar finish, and for similarly for pause the simulation for some time we are using our dollar stop. Okay, now time. So what if you want to print a time of your statement printing? Okay, so for example, if current time you have to print this statement, so at what time it is coming, so you will just add this dollar time here, and here you will get the number at what time it is printing. So your current time is printing, for example, 10 nanoseconds, so 10 nanosecond will come here. Okay, so returns the current simulation time, returns the current, but this is 10 nanosecond. What you want precise 10 point something, so you can use dollar real time for that, and similarly for rest time it's a higher precision time dollar task, you can say system task. Now this is file related task. I will not take much time in this one, because for fopen, fwrite, these are used for opening the file and writing on that file, but which we are not using that much, because in industry you will use Linux and everything, so Linux will do these things. You don't need this Verilog to do this all things. Okay, close. Yeah, these things are all there, but don't need it. Okay, so wherever you see dollar, it means some system task is there. So assertion is part of our system Verilog. I will make a separate playlist for system Verilog, or already created some videos on assertions, so you can watch that video. So but there are some system tasks related to assertions. Dollar fatal, dollar warning, dollar error. Dollar error is like this, so it will give error. Dollar fatal, sorry, dollar fatal is like this. The dollar error you can also use here, error. Warning also you can place. So the printing statement will have different color. For example, dollar fatal will have our orange color, dollar error will have our red color, and dollar warning will have orange color. So similarly you can use these things, but mostly using system Verilog, but there is something like this, therefore I have included in our video. Now
hit subscribe, like, and comment now. Let's begin the journey of verification.
For example of writing some system task, so module and module is our common thing, our system Verilog. So now in initial begin, we are writing dollar display for printing this statement. So in our terminal it will be starting simulation, then dollar monitor will print all these values. Dollar monitor will print at whatever time it is printing with dollar time. At the time will also get printed, like this hash 10 will also, then hash 20, because adding or summation whatever, but time will also print. Then again our start, so this is also printing here, this start is also printing here, this start is also printing, so everything is printing right now. And after that dollar finish will call, so and simulation will end, and it will say the end of simulation and something like this. So this is some normal example where we have used our system tasks. So thank you, and comment for more videos.
Please Lord give me a sign.